Good morning, lovely 12s. Right, buddies. We're rocking on in our amazing trig unit now. I really like this topic specifically, and I really like the next topics even more. So, yeah, we're getting into one of my favorite areas here, doing all the amazing trig. And today's title is Trig Identities. Now, you've probably not heard that word before in the context of maths, an identity. But an identity in maths is just something that is always true, no matter what. So in trig, you don't know these yet, but I'm just going to, well, they're on the screen, so maybe I guess you do know them. Here's something that's always true. Tan of theta is always equal to sine of theta over cos of theta. Now I'm going to show you why in a sec, but that's like always true. So in other words, if you put 30 degrees in, it would be true. If you put like, I don't know, 360 degrees in, it would still be true. So pretty much, no matter what number you put in, well, apart from making cos theta equal to 0, because that would break math, because that'd be dividing by 0, no matter what number you put in, this is always true. Now, you get to see a new notation then. See this thing here, triple equals sign? It's actually, I think they call it a triple bar, but it's just what they call an identity sign. You don't really need to be too fussed about the triple equals sign, but essentially, whenever you see it, you're not going to be able to solve this like an equation. So if I told you straight away that tan of, I don't know, that theta was 30 degrees, you wouldn't be able to mess about with this particular equation to figure out what a different value is, because the left-hand side is always equal to the right-hand side, and that's what this kind of triple bar thing denotes, this triple equals sign denotes. Same deal here, sine squared plus sine squared of theta plus cos squared of theta always equals 1. So I couldn't be like, well, if sine of theta was this, what would cos of theta be? Because it wouldn't work. You can't treat it like an equation. It's just always saying that this is always equal to that, no matter what the value of theta. Cool, right. Now, these are just the two trig identities that we're going to use in year 12, but there is actually dozens of them, and they're really good, and it's a really interesting, and I think a really fun topic to do. So, yeah, let's get started. Okay. So, number one, jot it into your book. Tan of theta is equal to sine theta over cos theta with the triple equal sign. Same deal here. Sine squared of theta plus cos squared of theta equals 1. Now, you've probably also never seen this sine squared of theta nonsense before, but this actually just means this. Sine of theta brackets squared. But because we don't want to put the brackets in, like you can put the squared here, where they've put it, where I've put it, after the end. So it's like sine squared of theta is the same as sine of theta squared. Okie doke, my buddies. You can't just, like, you wouldn't want to do it this way. You wouldn't make it like sine of theta squared, because if you wrote it that way, it wouldn't be clear if it was the trig ratio that was squared or if it was the angle that was squared, which actually makes a big difference. So say that sine of theta equals 4/5. If you squared that, you'd get 16 out of 25. But if you said sine of, I don't know, 30, and you were to sine of 30 squared, and you squared the 30 first, you'd be at like a great big number. You'd be like doing the squared, whatever number I just said, 9,000 or whatever the number was, that you would be doing the sine of, which is different. So yeah, that's why you write it that way. Cool. Right, buddies. So let's get into the good bit. I'm going to prove where both of these come from just using the definition of circles and triangles. So let's absolutely crush it. So first things first, on the left, tan of theta is always going to be sine of theta over cos of theta. Here is why. I've drawn here a circle. Okie doke, my lovelies. And in that, so it's just like cast as well. Or Sex and the City. I've just drawn a circle, okay, because everything is based on circles in trig. I know that we draw them as waves, but they are just based on circles. It's a circular concept. Okay, so here we go. It's a circle, and it's got this. Well, what's this blue line called, my lovelies? Well, if you said it's the radius, you'd be absolutely right. Now, here's what I'm going to do. I'm going to split it up, the radius, so that there is horizontal and vertical components. Now, how far we go along in the x direction is this, because this is still just the x direction and the y direction, right? So, how far we go along in the x direction, what would be a sensible variable for that? I know. How about x? How far we go up and down in the y direction, what would be a sensible variable for that? I know. How about y? Well, guess what, buddies? That, in itself, that little picture with the circle's radius and a theta, an angle drawn in there, is enough to solve the first thing already. So we want to show that tan of theta is equal to sine of theta over cos of theta. Well, check this out. Formal proof. So you write down this. Left hand side equals, and it equaled tan of theta, right? Okay. Now, tan of theta, my lovelies, what's tan of theta going to be in terms of this? It is right angled after all, because it's horizontal to vertical. Well, tan is opposite, which is this side over here, over adjacent, isn't it? It's TOA. So it's just going to be y over x. Okay, so you could write the left-hand side like that. What about the right-hand side? Well, the right-hand side is sine of theta over cos of theta. Well, what is sine of theta going to be? Well, it's sa ka toa, so O over h. So this is going to be x over r is what sine of theta is going to equal, over, and what's cos of theta equal? Y over r, I should have said actually even. So sine of theta is y over r because it's opposite over hypotenuse, and cos of theta then is going to be x over r. Cool beans, buddies. Can you spot anything way to tidy this up? I'm certainly not happy with the quadruple decker fraction. Yeah, well that's it. You times the top and bottom both by r is hopefully what you said, because the r's will cancel off the top, leaving you with y, and then the r's will cancel off the bottom, which is x. Which means, my buddies, the left-hand side equals the right-hand side. Which is proved. Done. Sometimes you just draw this little colored-in square, which just shows it's the end of a proof, if you like. Some people write QED as well, which is Latin, and I forget what it is. It's like Cod est demonstratus or something weird like that, but which means that it actually means which is what we set out to prove. That's what QED is. You don't put both, you put one or the other. I'm going to go with that one, and bish bash bosh. Cool. So that's it. Because you just showed in complete generality without any numbers at all. If you put a number in, you'd have been wrong. But in complete generality, you show the left-hand side is y over x. Then you did complete generality again. The right-hand side is y over x. Therefore, the left equals the right. And since I didn't use any numbers, that means this is always true. Tan of theta is always sine of theta over cos of theta. Boom. Okay, cool beans. This buddy here, this one here, my buddies, is going to be almost the same, and I'm almost going to spoil it a little bit, because this one has a special name. This is actually called the Pythagorean Identity. Okay, you don't have to know that. It won't even ask you that even once, but it is called that. And, well, I'll show you why, because that's how you prove it. So if you check it out, we've got this triangle here, right? And here's the thing. You know that x squared plus y squared is going to equal r squared, for sure, right? That's not in question. That's always true. No matter what quadrant you're in, it's still always true as well. Like even if it's spun down here, you'll just have negatives, but the squares will square them out and that'll fix it. Same deal here. If they're like Sex and the City takes care of the sign on the left-hand one, or the like sign of the positive or negative on the left-hand one, and here the squares take care of it. Cool. Well, guess what we're going to do? We're going to switch it around, though, my buddies, that we won't have x's or y's in. We want it all in terms of r. Well, here's the thing. To get rid of x, let's do it. Let's get rid of x. But for x, we're going to get this. It's going to be cos of theta is equal to x over r. So we're trying to get an equation just for x, which means x equals r cos theta. Cool? Now for y, it's going to be almost the same, except for it's going to be sine of theta is equal to y over r, which means y equals r sine theta. Cool? Now what we're going to do is we're going to put them both in. So put in. Well, instead of x squared then, we're going to have r cos theta squared. Instead of y, we're going to have r sine theta squared. And the other side is just r squared. Cool, 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 cool. Now all we got to do, my buddies, is we're just going to times both sides out. So this will become r squared. And then this is cos, like this would be cos theta all squared, or cos squared theta, the shorthand way of writing that, plus r squared sine squared theta, and that equals r squared. Well, we're one step away, buddies. What can we do to both sides? What can you do to both sides? What do they all have in common? That's right, they both have r squared. So what we're going to do is we're going to divide by r squared on both sides, leaving you just with cos squared theta plus sine squared theta equals 1, which is what we intended to prove. So that solves it. Proved, buddies. So we've just shown in complete generality that these things are always, always true, so it makes no odds whatsoever what value theta is. These are both true. Okay, now I like this topic, but it's a bit sneaky and a bit tricky, okay? So to start with, these are kind of easier ones, but they'll get silly hard, okay? The question's just to simplify, okay? All we want to do is write this in a more tidy manner. So here we go. Remember how I just said a minute ago that they're true regardless of the angle? So if I tripled the angle here, is it going to make any difference? Well, no, not really. Here, I'll even show it with full steps for you. Simplify that. Sine squared 3 theta plus let's just write it even. Sine squared 3 theta plus cos squared 3 theta. Well, check it out. Here it is with extra steps. Let A, or any letter, equal 3 theta. Then it's going to be sine squared A plus cos squared A. Okay, a bit like a disguised quadratic. Well, two squares added together, what does that make? 1. Bish bash bosh. The answer to A is 1, no matter what. Cool beans, buddies? Does that make sense all the way to the bank? Okay. B. B is easy. I think you should do B. Go. Okay, now if you said B is easy, yeah, but it's not quite so easy as you think. Yeah, maybe it is not super easy, but here we go. It's 5, take away 5, and here's what I'm going to say. See how it's sine squared theta? Well, if you look at this bad boy here, you could rewrite this identity that we've just got here. Well, we could write it as this. We could write down that sine squared theta is equal to 1 take cos squared theta. Do you see how we're just going to switch our identity around? That means that you can pop this in. 1 take cos squared theta, which means when you times it out, you're going to get 5 take 5 plus 5 cos squared theta. Cool. Which means that the answer is just 5 cos squared theta, like a boss. Okay. Now the same deal on C, my buddies. Now, I'm not going to make the substitution this time. Can you see how it says 2 theta and 2 theta? I'm actually going to maintain those throughout. I'm not actually going to make the substitution, okay? I'm going to not say let A equal 2 theta. I'm just going to solve it directly. So here we go for C. Well, here's what you're going to get then, buddies. The top is just sine of 2 theta. There's nothing you can do with that. Like, I could rewrite it if I wanted to as tan times cos from the first identity, but it's not going to help. So here we go. Sine of 2 theta, I'm going to keep chilling. Now, the square root of 1 take sine squared theta. What on earth can we do there? What's 1 take sine squared theta going to equal? Well, if you said cos squared theta, 2 theta it should be, you're absolutely right. Now here's why, in case you didn't spot it, with an extra step in, the bottom of this thing, so here's your extra step, so extra. You'll get really quick at spotting these, buddies. Your extra step would have been this, sine of 2 theta over the square root of 1 take, and then sine squared from the thing up here is going to be 1 take cos squared, 2 theta, which means it's just going to be sine 2 theta over, and this is going to be, the ones will go, and that'll turn positive, so it'll be the square root of cos squared of 2 theta. Happy? And that's where we are. Okay, now what was going on now, back to the black, is this. You're going to have sine of 2 theta on the top, and on the bottom, you're going to have just cos of 2 theta, because the square root will cancel the square. Now, sine of 2 theta over cos of 2 theta, does that look familiar to anybody? Anybody at all spot anything interesting that's going on here? Well, yeah, look, it's sine over cos. What does that always equal? Well, tan. So you got it. It's just going to be tan of 2 theta. Boom. There you go. The 3 of them simplified, buddies. So that would say those are kind of like easier level ones. And here we go. Let's go for standard hard level, okay? Boom. This is what's going to be on your exam, and this is what you're going to practice today, okay? I'm going to give you like a huge whack of time. This video might end up being like 25 minutes or something, but you'll still have a huge whack of time because these are tricky. Okay, now we're proving this. We will need to show that cos to the power of 4 theta takes sine to the power of 4 theta all over cos squared of theta is equal to 1 take tan squared of theta. Now, this is a proper trig proof. It's one of the things that students find the very hardest when they learn it, but believe me when I say you'll get into the swing of things soon. Okie doke. So here's what I'm going to suggest. You have to lay these out really carefully, okay? So what you're going to do is we're going to do a similar proof to this one, okay? Where there's going to be a left-hand side and a right-hand side, and then we're going to show that they're equal. So to begin with, step 1 in all of these trig proof questions is you look at both sides. You look at this side, you look at this side, and you say to yourself, which one is more complicated? Okay, well, which one is? Which one is more faffy? Certainly the left side, right? So here's what you're going to write down. You're going to write down LHS equals, and you're just going to put that left side. Cos to the power of 4 theta takes sine to the power of 4 theta over cos squared theta. Now, I've picked that side to start with because it's more complicated, and I picked the more complicated one because it gives us more to work with, okay? This is already simplified, the right, so I don't have anywhere to go with that, but the left is ugly, and I might be able to do some work with it. Okay, now, what we've got here, it's a bit tricky, and there's many ways of doing them. Sometimes there's a dead end, and sometimes there's not. Sometimes you hit a dead end, and sometimes you won't. Now, have a little think. What could we do to this, a cos, a sine, and a cos, in order to get to that? What would be something useful we could do you think? Okay. Now, I think I spot something really good, so I'm going to do the thing that I spot. Can you see that there's powers of 4, which is like a power of 2, take away another power of 2? I think the top, my buddies, is a difference of 2 squares. Alternatively, what you could have done is you could have divided both by cos squared, but I think that's going to be harder, I really do. So, I've spotted at the top that I think it's a difference of 2 squares, because this is like an x squared take 49 scenario. So here's how I can write it. I can write this as cos squared theta plus sine squared theta, and then the other one can be cos squared theta take sine squared theta. Happy that I've used a difference of 2 squares. The bottom stays the same. Cos squared theta. Okay, what do we spot next, my buddies? On my left-hand side here. Well, do you spot that? Does that look familiar anywhere? Cos squared plus sine squared. Well, yeah, look. That means that whole entire first bracket automatically for us is going to go to 1. So this whole bracket is going to be 1, which means we're just going to be left with cos squared theta take sine squared theta all over cos squared theta. Cool beans, buddies? Right, next step. Well, I can almost see the answer now. I see I'm supposed to have a 1 first. That's my next big hint that I see. I see the 1, and I'm thinking to myself, right, I can see that happening in mine too. So what I'm going to do is I'm going to split my, my fraction into 2 fractions. So I'm going to rewrite this as cos squared theta over cos squared theta take sine squared theta over cos squared theta. Happy with that? I just split the denominator, I split the numerator and put it over the denominator of cos squared. Well, cos squared divided by cos squared is 1, and sine divided by cos is tan from this one, so hopefully you spotted that as well. So here we go. See, there's only 2 of them, but see, it is tricky, isn't it? There you go, that's that being used. Sine over cos is 10, which means as they're both squared, it's just going to be 10 squared. 10 squared of theta, which if you noticed, is the right-hand side, which ends the proof. Cool beans, buddies? So we've shown that that's always true. No matter what happens, that's always, always true. So I hope that that's okay. I know it's tricky. And here we go. I'm doing this question for you, but this is actually in your homework. So if you want to keep watching, that's okay. If not, if you'd like to just stop now because you think you have the idea, you'd like to just get stuck in, just get some practice, don't watch me do this then. Try that. It's page 212, question 5. Now, this one's 5b, okay? So there's like about 5 or 6 questions in question 5 for you to do, and I want you to spend literally 40 minutes on this. And I'm on the chat if you need anything. So ask for help. You need to just practice, practice, practice. Just go for it, okay? They're hard and they're fun, and I want you to try them, okay? So that's what I'm going to get you to do. Cool? So I'm going to do this question, but if you feel like you want to have a little go on your own first, they're just like this. If you want to have a little go on your own first, go. And if you've stuck around for me, here we go. Let's work on it together, buddies. Okay. Now this question here, it's still an ugly one, okay? So it's a tricky proving question. It does give us the thing that cos of theta doesn't equal 0. That's just in order for maths not to break, because if cos of theta was 0, it'd be like dividing by 0. Cool. So here's what we're going to do. We're going to approach this the same way as the last one. We're going to start with the left-hand side. The left-hand side, because even though this one can be simplified a bit, this is ugly because of the fractions. So the left-hand side, my buddies, was this. It's 1 over cos theta. Take away cos theta. Now for me, straight away, I look to the right-hand side and I'm like, well, there's no fraction on the right. Okay, there's no fraction to be had on the right. So I don't want there to be a fraction anymore on the left. So what am I going to do to kill the fraction on the left? Well, we could combine them then as a single fraction, okay? That's what we're going to do. Now here's how. You put this one over 1, and you're just going to do the common denominator thing, so either times this one by cos of theta, times that by cos of theta, and times this by 1, and times that by 1. That's the way you would have learned that in Key Stage 3, but there's also the quicker cross multiply way, which is the way I'm going to do. So you could also just cross multiply. So cross multiply again looks like this. 1 times 1 for 1. Cos times cos for cos squared, and it's a minus, so minus cos squared theta, and that's all going to be on top of cos of theta. Cool beans, because the bottom one is them times together with your cross multiplying. Okay, so here we go, my buddies. What we're going to find next then is 1 take cos squared of theta. Can you think of anything useful there? Have you seen something in this format before? A squared trig ratio. Oh yeah, buddies, it's this again, isn't it? It's this again. 1 take cos squared is going to be sine squared. And the reason for that is this. Rewrite this. Sine squared theta is 1 take cos squared theta. Cool? Which means this is going to be sine squared theta. So on this side, you're going to get sine squared theta over cos squared theta. Or sorry, just regular cos theta. Now we still don't have the final answer yet. It's supposed to be sine tan. But we do know that tan is sine over cos, right? Again, so we're using this one again. Sine over cos. I do have a sine over cos, but the trouble is I have a sine squared over cos. So in other words, I do have something like this. I could rewrite this as sine of theta times sine of theta over cos of theta. Do you agree? Because sine squared is like sine times sine. Because if you do it that way, buddies, look, that matches up perfect with the blue up there. Which means you're going to be left with sine of theta out front, and sine over cos is tan of theta, which equals the right-hand side, which is what we set out to prove. Cool. I am conscious these are tricky. They're not too tricky though. You've just seen the steps, okay? Essentially, you start from wherever's ugliest, and you start popping numbers in to make it work. If ever you get stuck, you're allowed to stop working on the right-hand side and stop working on the left-hand side, and start working on the right-hand side, because if you do a left-hand side and get halfway done, then a right-hand side and get halfway done, but they end up both being the same halfway done answer together, that proves it also, because you could just backtrack through. As long as you can at some stage say the left equals the right, then you're all done. So here's what you're going to do. Page 212, question 5, every single one of them. I'm on the chat if you need help, and good luck. Right, you've got it. Good luck, buddies. See you next time. Bye, buddies.